Hello everyone. Today's discussion is for class 12 and the topic is aromatic aldehyde and in particular benzaldehyde. So first we will be discussing about laboratory preparation of benzaldehyde. So benzaldehyde can be prepared in the lab by oxidizing it with chromite chloride. Okay, so benzaldehyde can be obtained in the lab from toluene by treating it with chromite chloride, and in the second step we are going to hydrolyze it. So this molecule is toluene. When toluene is oxidized with chromite chloride, please look at the formula for chromite chloride. It is CrO2 Cl2, and CS2, which is carbon disulfide, is the solvent. Okay, so oxidation takes place and this CS2 group will be converted into CO2. Now benzene ring with CO2 group is benzaldehyde. Now the second topic for today's discussion is Benzene condensation. So the second topic for today's discussion is Benzene condensation. So this Benzene condensation is given by those aromatic aldehyde whenever it is treated with alcoholic potassium cyanide. Let me repeat. When aromatic aldehyde is treated with alcoholic potassium cyanide, it undergoes self condensation to form the product benzene. So let me write the reaction. This is benzaldehyde. Now for this reaction, we need two molecules of benzaldehyde. So this is one molecule, and the molecule, whenever it is treated in presence of alcoholic potassium cyanide, then condensation of these two molecules will take place. Now, in our previous class, we had discussed about aldol condensation. So, in that, I had taught you how to predict the product in just one single step. Same step will also be followed in this case. So, in benzene condensation, this hydrogen will be going to this oxygen. Okay? And formation of bond between this carbon and this carbon takes place. So these two molecules will be joined together or condensed to give one particular molecule, which is known as benzene. So let me write the product. So I'm writing the product here. OH. This H I'm writing it here. This H hydrogen is here, and now the bond formation between this carbon and this carbon takes place. So this carbon is bonded with this carbon. See, double bond O, benzene ring. Now this particular compound is known as benzene. So the name itself suggests, see, two benzene rings. Benzene means two benzene rings are joined together or condensed to give you one single product. And the condensation, please don't forget, the joining of these two particular benzaldehyde takes place through this carbon and this carbon. Not the ring carbons are involved. Okay, so this is our benzene condensation. the next reaction that we are going to do today is Perkins reaction. The next topic is Perkins reaction. Now, in Perkins reaction, here also aromatic aldehyde. Okay, here we are discussing about benzaldehyde. So, whenever benzaldehyde is treated with acetic anhydride, and in presence of sodium acetate, then what happens? The condensation between this benzaldehyde and acetic anhydride takes place to form one single compound, main compound, that is alpha beta unsaturated acid. So once I write the reaction here, it becomes more clear. Please look at it very carefully. So we are discussing about Perkins reaction. So aromatic aldehyde, and in this case we are taking benzaldehyde. Whenever it reacts with acetic anhydride, please remember the formula of acetic anhydride. It is CH3, C double bond O, C double bond O. Now here also it is CH3 in presence of sodium acetate, that is CH3, COONA. And if it is heated, what happens? The condensation reaction takes place. Okay. Now let me write CH3 as CHH2 so that I could show you how the reaction takes place. So CH, I'm writing CH3 as CHH2. Okay. So this CH3 I have written as CHH2. That means it's CH3 itself. So whenever it is heated in presence of sodium as acetate, a molecule of water gets eliminated. Look here, this oxygen and this hydrogen, H2O gets eliminated, and the bond formation between this carbon and this carbon takes place. And remember, here it is double bond. So let me write it out. Now this part I am writing here in the scripture. Double bond O, double bond CH, C double bond O, C double bond O, CH3. So this is our main product. And what is eliminated? Water molecule is eliminated, minus H2O. Now, since in this reaction condition, we already have what? Water molecule. Now, addition of water molecule takes place. So, let me write H2O as HOH so that you could understand how the reaction takes place. So, this OH part of water molecule will be bonded with this carbon. Okay, will be bonded with this carbon. Whenever it will be bonded, this bond between this carbon and this oxygen breaks. Okay, and this hydrogen now, since the bond has broken away, this is having O minus sign. This minus sign, O minus, will attract this proton. That is OH. This H will come here and get bonded with this oxygen. Please remember, the bond between this carbon and this oxygen has clipped. So now, here I am getting a different or separate product, and here the separate product. Now in this product, this OH group has come and bonded with this carbon, and in the second product, this hydrogen comes and gets bonded with this oxygen. So let me write this product first. So I have benzene ring here, CH double bond C H. So I have this hydrogen here. So let me write this hydrogen. This hydrogen. Okay. CH double bond CH, and now here's it COOH. Now this carbon is bonded with this oxygen also and this OH also. So we will be getting COOH. And here in this product it is CS3 COOH. So this is acetic acid, and our main product is cinnamic acid. So the name of this compound is cinnamic acid, which is this is functional group alpha carbon, this is beta carbon. So alpha, beta, unsaturated, double bond is present, therefore unsaturated carboxylic acid. Okay, so please look at it very carefully, write these reactions and keep on practicing until you become good at it. So now moving on to the next topic for today's discussion, we are going to discuss about electrophilic substitution reaction of benzandelyde. As we have already discussed about electrophilic substitution reactions in class 11 as well as in class 12 in our previous classes. So electrophilic substitution reaction, electrophilic substitution reaction. And in electrophilic substitution reaction, the first one we are going to discuss today is halogenation. Halogenation. We are discussing about benzandelyde. So let me take this example. Benzandelyde, C double bond OH. So C double bond OH. Okay? Here you have to be very, very careful. Like in other cases, in case of electrophilic substitution reaction, usually the substitution takes place inside the ring, either at ortho position, meta position, or para position. It depends upon whether it contains electron withdrawing group or electron donating group. I have given you the complete note of it. Please revise that. Okay? Before discussing this, before coming to this part, please revise that portion. Here, why this benzandelyde, halogenation of benzandelyde is little different? Because here, whenever it is treated with, say, chlorine, halogenation in the ring part, that is in the benzene ring, is very difficult. Why? Because the side chain reaction takes place. Means this chlorine will substitute this hydrogen more faster, okay, and hence you will be getting side chain halogenation reaction. Please remember this. So let me write this reaction. C double bond O. This hydrogen has been substituted with chlorine. And what is your byproduct? This hydrogen, one hydrogen from here, one chlorine from here will give you HCl. So let me repeat it once again. Halogenation in benzaldehyde takes place more readily along the side chain and not in the benzene ring. Okay? Now, let's move on to the next electrophilic substitution reaction, that is nitration of benzaldehyde. The next topic is nitration of benzaldehyde. Nitration. So, benzaldehyde, C double bond O H. Whenever treated with concentrated nitric acid HNO3 and in presence of concentrated sulfuric acid, what will happen? Nitration takes place. Now this 2 condition will generate NO2 plus. Okay, now this NO2 plus will be added either to water position or meta position or para position depending upon whether electron withdrawing group is present or electron donating group is present. So here, since C double bond O is electron withdrawing group from the ring, therefore in such cases, this nitration, this electrophile will be directed towards meta position. Now see, if it is electron withdrawing group, then ortho position as well as para positions will be having positive sign. Okay, we have already discussed this. Let's go through this one. Okay, go through it. Now this positive charge will be repelled at ortho position and para position. Therefore, it has only one choice, that is going at meta position. So you will be getting C double bond O H and O2 coming at meta position. This is meta position. Okay? Please remember this. Now, the next topic is sulfonation. Okay? The next topic is what? The next topic is sulfonation. Number 3, sulfonation. We are discussing about benzaldehyde. So let's take benzaldehyde, C double bond O H. Now whenever it is treated with concentrated sulfuric acid, addition of SO3H takes place at meta position, as we have discussed in case of what? Nitration. Why? So here C double bond O H. Okay? Now from this condition, what will you get? You will be getting SO3 as H coming at meta position here, because electron withdrawing group positive at ortho and para position. Therefore, this SO3H group can come at meta position. Okay? Now, in electrophilic substitution reaction, if you have generally speaking, if you have electron withdrawing group, then substitution takes place at meta position. And if you have ortho para directing group, then the incoming electrophile will come at either ortho position or meta, ortho position or para position. Okay? So this This was for today's discussion. Now, let me give you some assignment. Now, at the end of this particular chapter, you have so many ISC questions, and out of those ISC questions, you will be solving ISC questions of 2016. Let me repeat. ISC questions that came in 2016. 20 ISC questions 2016. Let's solve all the questions and WhatsApp me. So take care till we meet again in the next video.